Hi, this is Tanvir Ahmad and my teammate is Chaitanya. We are team 9. We were working on object detection on non-iconic images this semester. Let's go to the description of the project. As we know, there are several models that were implemented to detect objects on iconic images, but in real world the environment is cluttered. So we took this as a challenge and tried doing object detection on non-iconic images. Initially, we focused our efforts on building an efficient and accurate live object detection on small data set like stationary data sets which consists of calculator, pencil, eraser, etc. in an image. We created a model and then we trained our we created our model using layer separation for object classification, object localization using faster RCN, and we trained our model with non-iconic um, images that we took from the data set and took from the internet. We did data cleaning, pre-processing stuff and all, and then later we used TensorFlow and computer vision's OpenCV to do live object detection. We will see them in a bit. The dataset we used were Coco dataset, and we also used our own stationary dataset to get images of stationary objects. Then like what we did in pre-processing and cleaning is after gathering of these images, we resize adjust the resolution of those images and label the bounding boxes using labelmg tool, and then we wrote the code to convert these XML files generated by labelmg to CSV files, then a code to get TF records out of these CSV files. This is the preview of iconic versus non-iconic environment. Um, as you can see that in a non-iconic environment, there isn't one major object. There are 2, 3, 4, maybe 10 objects which have equal importance. For suppose in this image, a man, a ball, and a racket, and a tennis court, etc. Project implementation. When it comes to implementation, this we have already presented in our previous presentations. So like I'll just give you the brief overview. Use TensorFlow, Protobuf of Google, etc., and fast RCN model to train it and test it. This also we have mentioned in our presentations, model versus the models in the reference paper. What's the different approach we took, what kind of to enhance accuracy and faster results we are using faster RCN, and this we also showed that when we tested our model on images, this was the output we got. uh, this is what I want to talk about in the talk about in this presentation. That is what was improved and what we did after our previous presentation. We implemented a camera based app to do live object detection using our webcam in the laptop, even though my laptop is pretty old and the cam is not that great, but still we went ahead and did it. We evaluated our project and we saw pretty decent results. So like we felt that these results were good enough to build a surveillance system, so we went ahead and built a surveillance system that detects the coordinates of the live objects. The system can be useful to prevent to supervise in manufacturing plants, monitoring traffic and controlling traffic lights, or for security purposes as well. This was implemented using TensorFlow Object Detection API and use of transfer learning to train the model, and OpenCV for to access OpenCV for to access camera and do live object detection. These are reference papers. Let me show you how it is actually done. I have a couple of notebooks, Jupyter notebooks. I will show you first basically the live object detection on our stationary objects. Let me run this file. Yeah, it basically takes some time and opens the webcam of my laptop, and then I can show objects in front of the webcam and it will detect these objects. Let me do that. Suppose right now I'm showing a pencil in front of the laptop, so it is able to detect it as a pencil. The accuracy is pretty good, but I'm holding the pencil and it is shaking a little bit, and the cam is not really good, so it is not able to focus it correctly, but it will be able to show pretty good accuracy, 99%. Let's try another object like calculator. Let's see what it's going to show. um, uh, let's see. Yes, I think it is doing a pretty decent job of detecting it as a calculator. It is showing it as a 99% accuracy to show it as a calculator. That is actually it is doing a pretty good job. Unfortunately, I don't know where my eraser is, so it works for the eraser as well. I'll show you the test images where it worked on eraser as well. Let's quit this app. Now let's see how the Coco dataset is performing on our model with live object detection. Let me run this. um, it opens a it takes some time to open the web app, and let's see what it can detect. It actually opened pretty fast this time, so let's see. It's able to detect it as a bottle. Actually it is doing a pretty good job of detecting it as a bottle. uh, Pretty good job of detecting this as a bottle. Let's try with some other item. Let's try with my cell phone. Let's see what it detects. Yes, it is detecting cell phone with a pretty good accuracy. Let's try with other items. uh, let's try with other items. Yes, it is able to detect knife with a pretty good accuracy as well. uh, let's try with uh, it's actually detecting my hand. uh, it's detecting as a cup, bowl, vase. It is fluctuating, but it is doing a pretty good job. When it turn this way, it is doing a decent job of detecting as a bowl. uh, so this is what our app does on live detection on Coco dataset does. So as I told, we have built a surveillance system as well. Let me show you that as well. uh, this is the surveillance system folder. I'm going to run this surveillance underscore system.py file. As you can see, there is no results folder here. Once I run that file, it is going to get generated. Let me run this Python file. Now app opens and the surveillance system gets started. Those images, and it will show you what all the images it captured. Let's see that how it is doing now. This is its frame as of now. Let's see what is able to detect now. If suppose I have showed a knife to it, let's see whether it is able to detect a knife or not. It's detecting my hand as of now, and it is yes, it detected this as a knife. As you can see, it detected this as a knife. As I said, my camera is not that good, but still it is able to detecting this as a knife. Let's check with my phone. um, yes, this is detecting my phone pretty good with pretty good accuracy. It is able to detect my phone. Let's see whether it can detect me. Let me turn my laptop towards me. Yes, it's able to detect me as a person. Let's see our results folder. This is our results folder. Yes, it's did a pretty decent job of actually detect different positions of the knife and different positions of my phone, one when it is switched on, when it is switched off, and me while talking actually did a pretty decent job of detecting the items. This is what our surveillance system does. Basically what we thought of enhancing the surveillance system is like, suppose yes it detected if suppose this scam is in front of a house, it detected a person who is standing in front of a house, but that doesn't help us actually, because like this person can be a stranger or his might be neighbor, friend, or a salesman. But what if a person is holding a gun or a knife? It should be able to detect those instances where the person looks suspicious. For suppose a person is wearing a mask, then the person is supposed to be suspicious. These kind of scenarios we thought of working on, but for this as the time it's the because of the time constraint, we thought of stopping it here for the sake of this project. But I feel like I can work on this sometime later. This is what we did in this project. Thank you. We would like to thank you, Professor, for giving us the opportunity to work on this project. Thank you again.